Welcome everyone to our webinar, the next installment of the best practice webinar series that we've been holding here at Highwire for the past few years. This one is strengthening research integrity, the tools of the trade. In our last webinar, we discussed research integrity at a high level. We caught up with the latest developments around the STM Research Integrity Hub, which is an industry-wide effort to fight research fraud. We learned about image manipulation, the impact of paper mills, and the influence of generative AI on the scientific literature. And we got a summary of some of the most impactful presentations from the 2024 World Conference on Research Integrity, describing the worldwide effects to detect and prevent research misconduct. And you can access that webinar on our YouTube channel, but because of the sensitive nature of some of what we covered, that recording is protected. And so you can contact us to get access to that webinar. And my colleague Kushal can drop that in the chat of how to request access. So today we're going to continue the conversation by exploring some of the most advanced tools available to help editorial offices and publishers uphold research integrity. Some of the topics that our panelists will discuss include what problems are these tools solving, how do these tools fit into the workflow, what information should be made available to authors, and how can transparency be balanced to maximize the effectiveness of integrity checks. But first, we need, before we get to the main event, we need to do some housekeeping. This webinar is being recorded, and that recording will be available and shared after the meeting. And please please put your questions in the question box as you think of them. We will answer those questions at the end during the half-hour Q&A. So again, as you think of questions, please put them in the question box. We'll be collating those, and we will use those questions as part of our discussion. So, research integrity, it lies at the heart of scholarly publishing. It's what helps maintain trust between researchers, publishers, and the public. Without rigorous integrity checks, we risk publishing scholarship that may be unreliable, unethical, or even fraudulent. It not only damages the credibility of individual researchers, but it can also harm the credibility of science in general, and harm the reputation of journals and publishers. So strengthening research integrity means ensuring that that published research is reproducible, it's transparent, it's credible, qualities that are crucial for driving innovation and progress. So we'll now look at 4 powerful tools that help editorial offices screen manuscripts for research integrity issues. We have DK Suljana, the director at AAMC's Convey. We have Martine Rolandes and Anita Bendrowski, both of SciCrunch, talking about SciScore. We have Tim Vines from Dataseer, and we have Adam Day of Clear Skies talking about paper mill alarm. So I'm going to now hand it over to DK. So I'm going to stop sharing, and DK, please take it away.
Yep. Thank you, Tony. 1 second. I'm just going to go ahead and share my screen here. All right. Hopefully you're able to see my first slide.
Yep, no problem.
Perfect. All right. Well, thank you, Tony, for that warm introduction. And thank you all for joining the panel today to discuss the various tools available to increase transparency within the scientific community.
DK, we do see the presenter mode, so I don't know if that's
Apologize for that. 1 second. Sure, screen 2. Okay, should just be the slides now.
That's perfect.
Perfect. I will be discussing the AAMC, the Association of American Medical Colleges disclosure platform known as Convey. Many of you may have heard of it. But the goal today is to essentially tell you a little more about what Convey does. So what is Convey? It is a tool that improves the disclosure, submission, and collection process for both individuals and for organizations. It is a platform that places the control in the hands of societies and publishers by allowing them to thoroughly capture relationship disclosures from authors, reviewers, editors, board members, and many others while reducing the burden on the individual by allowing them to create and maintain a reusable repository of their relationships, whether those be financial or non-financial. So a little background on how Convey came about under the AAMC portfolio. If you are familiar with the AAMC, it is also known as the Association of American Medical Colleges. They have been serving the academic medicine community for about 148 years by providing services, products, and resources to help tomorrow's physicians and researchers. They support roughly about 171 accredited US and Canadian medical schools and over 400 teaching hospitals. And they are a reputable source in the community for various different services, such as the medical school application service, the electronic residency application service, and also administering the MCAT exam. So a little background on sort of why the AAMC even thought of coming into this area of developing a conflict of interest or disclosure collection system. It really was based off of a report that was published back in 2009 by the Institute of Medicine, now known as the National Academies. The report was titled Conflict of Interest in Medical Research, Education, and Practice, and it discussed the disjointedness in the process for submitting disclosures and the taxing process and the burden that it caused for researchers. In this report, there were many other administrative issues that were discussed, but nonetheless, disclosures was one of the primary focuses. And after this report, multiple discussions took place via stakeholder events and working groups, which led to the final recommendation from the National Academies from their implementation committee that a not-for-profit organization handle the development of such a large system. And that is when the AAMC stepped into this space to develop what we now know as Convey. The AAMC also teamed up with an external group, which at the time used to be under the Johns Hopkins University, known as Medbiquitous. They are a data health standards organization to help create a data standard, which could be a uniform data set that would allow Convey to be agnostic to the type of organization that is collecting disclosures. And that is key, and I'll get to that in just a second, but that is essentially the core of what Convey was built on, was those data standards that were uniform across different types of organizations. And so what Medbiquitous did at the time was they brought representatives together from various different areas, government agencies, journals, continuing education, publishers, academic medical centers, vendors from different areas, to essentially look at all the different types of data fields that are being captured as part of the different forms that are being utilized, so that they could come up with this uniform set of data standards. And the reason why that was key is because Convey is really designed to not just help publishers and journals, it is also designed to help organizations, any in any area, in any field that have a need to collect disclosures. So at this point, you may be wondering, why is a disclosure system specifically needed? Doesn't our current process support this activity adequately? Well, the problem of incomplete, inconsistent disclosure collections continues to be the persistent problem that Convey was developed to address by providing a centralized repository for disclosures to increase efficiency of collections and facilitate transparency. On this slide, you see a handful of headlines that highlight the risk of COI and the perception of COI's impact on public trust in science, trust in healthcare, and in drug companies. Why does this happen? Well, the process for disclosure submission is very disjointed and cumbersome. It requires individuals to utilize various different methods and different applications to submit their information by entering data repeatedly for their various activities. A researcher or an author is not only submitting a disclosure to journals in support of their manuscript, but also perhaps speaking at a conference where there may be continuing education credits offered, which ultimately also requires the person to submit a disclosure. And it is based on a different set of requirements as per that society or organization's needs. And if this person also happens to be serving on a clinical guideline committee, for example, with an academic or scientific society, that is yet another disclosure that comes into the mix. And so with all of these varying processes, it leads to inconsistencies in the information that is submitted across the ecosystem. So how does Convey help strengthen that trust in research? Convey is embedded in the scholarly and scientific workflow and used for many different types of what we refer to as disclosure events. So for example, annual faculty review, article submissions, editorial board appointments, CME credits, which is the CME for the continuing medical education credits at conferences, and even for journal articles for some organizations. It is the only system that not only supports the journals and publishers, but also supports societies and academic medical centers. By creating a system that facilitates disclosure collection for the various types of disclosure events, Convey supports the researcher anywhere in their journey as they move from being just a researcher to now being an author, perhaps also serving on the editorial board or speaking at a conference. The ultimate goal for Convey is to elevate the trust in the information received by the organizations by reducing the number of corrections and retractions for publications, conference materials, and perhaps even resignations of leading researchers due to their lack of transparency in disclosure submissions. We frequently have organizations where they recognize the value of not just supporting the author as part of the journal workflow, but also that same author now serving as a member across the organization, across the society in multiple different roles to also adopt Convey for those various different purposes and activities as well. Convey has integrations and strategic partnerships with key contributors within the scholarly ecosystem, including the continuing medical education applications, peer review management systems, access management platforms, professional societies, and standards organizations to create a more standardized and streamlined process. These integrations include Elsevier's editorial manager and Wiley's eJournal Press peer review systems, ORCID, and the US government's open payment system, and of course, not to forget MPS's Digicore Pro, along with many others. Just taking a quick glance at Convey overall, It has helped improve the disclosure submission and collection process for both individuals and organizations. It is the core community for Convey is comprised, as I mentioned, of scientific societies, publishers, and academic medical centers. To highlight some of the growth realized by Convey since its launch, there are currently over 375,000 disclosures in the system, and roughly about 25% of those are returning disclosures. So there is definitely that value that is being recognized by the community to really streamline this disclosure collection process and have continuity between the data that is not just submitted to their journals or to their societies, but across the entire spectrum. Fairly quick, easy, simple process for an organization to get set up with using Convey. It's a four-step implementation process. Not going to get into the nuances of all of this, but roughly just want to highlight that it is a very simple system to use and get set up with should you want to explore further with viewing the organizational side of Convey. But today, really what I want to focus on is showing you from a disclosure perspective, from an individual's perspective, how Convey can really truly benefit their experience within not just this tool, but their experience as far as engaging with the various different journals, societies, and organizations across the academic landscape. So for an individual, they begin when they receive a request from an organization that uses Convey, or they can actually independently use Convey as just a repository for all of their disclosures. The first step, as soon as they have successfully logged into the application, they are brought to the landing page where they are presented with the instructions for the organization that is requesting their disclosure. Once they read those instructions and they move to the next step in the process, they are guided to enter in their relationships, whether these be financial or non-financial, and the system walks them through step by step in guiding them in entering in their data. Here are those interest types that I mentioned earlier that were developed in collaboration with Medbiquitous to ensure that Convey is able to support not just publishers and journals, but also those other organizations that are key in this space. Following the entry of all of their relationships, the requesting organization does have the ability to tailor some specific questions that they may want to have responses from the disclosures filled in. And that is what this third step of the workflow identifies here. And the final step in the workflow is essentially a review and send. Very simple process, but the true benefit of Convey comes into play when that individual is coming back in for a second or a third or a fifth, etc. disclosure. There's been noticed a 40% time savings for those repeat disclosures. A first-time disclosure through Convey spends on average roughly about 20 minutes submitting a disclosure. However, that subsequent disclosure is reduced by an average of 8 to 10 minutes, depending on the complexity of those additional questions. Again, we are now the same individual coming in, submitting a disclosure to a different organization. You will notice that I am now sending this disclosure to a sample ICMJE policy. And so the instructions look different because they are different than that previous submission that we just walked through. But the benefit of Convey comes into play on this second step, which is where their interests are listed. The first time someone goes through the application, they obviously will not have any relationships listed because they've never used the system. However, it's this subsequent disclosure where all of their interests are listed out for them And not just that, Convey takes it one step further and actually goes ahead and identifies and categorizes interests that are not needed based on the requesting organization's requirements in this application. So as you see on the screen here, there is a call out for this last column, which is the reason why these interests are not being included in this person's submission. So again, Convey tries to simplify things. It's not deleting anything out of the person's repository. It's keeping everything in the repository, but helping the process be a bit more streamlined and efficient for the individual by also taking into account the receiving organization's requirements. And then the third step, similar to what we saw in the first submission, these are additional questions that are tailored specific to that receiving organization. And the final step in the workflow, which remains the same, that is the review and send. And with that, that subsequent disclosure has been submitted. So that is, at a very high level, what Convey is designed to do, and how it has been working within the community to help alleviate those pain points of having the redundancy of data entry and the inconsistencies that organizations receive when they do have those disclosure submissions. So with that, I'm going to end my part and stop sharing and hand it off to our next speaker.
And while Anita is and Martina getting that ready, I just want to remind people to drop questions into the Q&A box, and so that we can answer those later on.
All right. Can you see my slides okay?
Yep, we can see them just fine.
Okay, perfect. So thanks for the warm introduction, Tony. And yeah, being an AI company, I thought, okay, let's ask ChatGPT whether they can summarize our slide in one picture, in a nice infographic, which is what this is. As you can see, even for me, it's very hard to make any sense of this. But the good news is that SciScore can do a whole lot better. So let's start talking about that. Anita, over to you. Oh, you're mute.
Thank you. Sorry about that. So SciScore is a tool that can really address some of the big ticket items in the reproducibility crisis. This is again the Friedman graphic that's actually pretty common, but it breaks down reproducibility by numbers, by the number of dollars that is wasted in research due to poor practices. And what you'll see is that primarily we focus on the top two, which is the biological reagents and reference materials, as well as study design aspects. And biological reagents are key resources we'll talk a whole lot about, and in terms of the RRIDs, which I'll get into next time. But study design elements like randomization, blinding, and other things like that are incredibly important, because what they do is they decrease effect sizes across the board. So every time Malcolm McLeod's lab has looked at an overall picture of any disease area or any area of research, when you have hypothesis testing and you don't blind and you don't properly randomize your samples, what ends up happening is that you get a wishful thinking size of an effect as opposed to a real size of effect. And that has real implications in terms of clinical trials failing because they do not prescribe to wishful thinking. They actually look for real effects. SciScore also touches on data analysis and reporting, as well as laboratory and clinical protocols, but I think Tim Vines will address the data reporting in much more detail with his tools. So getting back to the research resources, the reagents that are used, there is a project that I have led for 10 years, along with a whole lot of colleagues. It was started out of a set of journals. There were 25 journals that came into the NIH. We had hammered out an agreement in 2013 to basically look for things that seemed to not be identified well. And this is just a representation of those things. So things like mice, flies, rats, pigs, antibodies were a really big driver of this. About half the antibodies don't work. And the ones that we list in our papers are not easily findable. Biosamples and cell lines, all of these projects, individual resource centers are actually part of a single unified web portal, the RID portal, where there's a lot of other information that gets fed both from literature mining pipelines from the RIDs that authors use themselves into these individual records, and projects such as the International Cell Line Authentication Committee and a lot of validation and verification projects. And in 2024, we have just achieved the 501c3 nonprofit status, and we will be moving a lot of our activities over the next few years into that nascent nonprofit. So how do we actually improve reproducibility? There are many, many checklists that are used. You've heard about one, but there are many more for animal experiments. There is the ARRIVE guideline, there's PRISMA, there are CONSORT guidelines for clinical trials and others. Now, these are a lot of guidelines. And so we thought, hey, why not simplify this? So we developed a lot of algorithms against various rigor criteria guidelines. And if you look at the kinds of things that all the guidelines are asking about, many of the items are in common. So for example, here is just the list of guidelines 1 through 5 from MDAR, ARRIVE, CONSORT, veterinary guidelines, and the Landis criteria from the NIH. And they largely talk about very similar things like inclusion-exclusion criteria, randomization, blinding. Sex as a biological variable is present in some set of questions across every single guideline. But lots and lots of other guidelines, including ones for antibodies, cell lines, organisms, those are those reagents that are absolutely critical to be able to address the reproducibility crisis, and of course, code and data sharing, all very important. So SciScore has been integrated in eJournal Press and in Editorial Manager for about 6 years now, 5 or 6 years. And what it basically means is that when the author actually comes into their favorite journal that is on board, they will copy and paste their method section into a special box. Within about a minute, an email usually comes back, and that information, along with a report, is available in the journal submission system. And then that journal can be downloaded by the author and acted on. We have reviewers looking at these reports. We have just editors looking at reports. We have authors looking at the reports. That is all up to the journal to decide. But this is what a report looks like now. There's always a summary page. That summary page is different for various guidelines. So in this case, animals were detected, and so the report actually follows the ARRIVE guidelines and detects or not detects each of the items that are available through the ARRIVE. So here you can see that there's an ethics section with the IRB, the consent statement, IUCUC. There are also field sample permits, euthanasia, and agents that could be found. They weren't found in this particular report. In terms of rigor adherence, this author listed subject demographics, but not attrition. And here is a summary of the key resources that are being used. Each of these items is actually followed with a lot of instructions on the SciCrunch website. And so, for example, if sex as a biological variable is not detected, but it is expected because an animal is detected or an iocuc is detected, then we have a set of instructions here that basically says, hey, add a sentence to your method section. Martijn, do you want to take the next? I think I was supposed to not do the report discussion.
Yeah, no problem. The second part of the report is still very similar to the older version. So we list all the sentences that are being used in the report or in the article, and if they are adherent with the guideline that we check for, you will see a green box, a green tick box. And as Anita mentioned, if it's not, then there will be some pointers and some text to say how you can be compliant with this. What's very new in version 3 is that we have a statistics module. What we want to do is really to help the authors how to report on statistics and remind them which data sets need to be included. And so, for example, here on the t-test, if you have a t-test in your paper, you need these items somewhere in the method section. And we have also more examples and information on the website. We currently test for these 14 statistical tests, and more might follow later on. Now, we also have been working, of course, with publishers for already quite some years, some of them. And we have published a number of papers studying what the effect is of SciScore on the whole peer review process. And I'll take you through them step by step. So the first is that if you use the RIDs that Anita mentioned, actually, of course, the resource identifiability will go up, and it decreases, for example, the misuse of troublesome cell lines. Now, the good thing is when you work with SciScore, actually we see a rise to 50% of the papers including RIDs in their method section. And so we see here an example. The green line is a journal working with us, and the blue line is a journal not working with us. And we see that the uptake for the AACR paper is huge. Now, over time, we've also looked at the average score. So each paper gets a score. If you take a lot of papers and we call it a journal, you can look at that, but we can also look at all of PubMed Central, the open access set, and look at the average scores per year. And we see that the average score goes up, but it lags a little bit here. We'll be running with the new version of SciScore, PubMed Central, all over again in the next couple of weeks, months, and we'll be able to give you an update where the score is at the moment. We see here that if we look in detail why the scores went up, that's, for example, due to the software identifiability, but the antibody identifiability lags behind. Now, what's the meaning of this score? If we look at the cancer reproducibility project, we see that if you take the original papers, the score was 3.3 on average, and the researchers worked on these papers to get better methods, first the registered report and then the final replication study, when they were able to replicate the data, and then the score goes up. Now, more interesting maybe for the publishers that are attending this webinar, what happens between submission and revision. Now, we've looked at a lot of journals over time, and actually time over time we see, and whether you work with SciScore or not doesn't matter too much, we see that actually the score goes up. So hooray for peer review. We go from, we always see an increase from original submission to revision. Last but not least, what we see also over time is that the longer a journal works with SciScore, the more that the scores diverge between accepted and rejected papers. And so we see that's going up to half a point to a point here towards the end between the accepted and rejected manuscripts, with the rejected manuscripts lower scores and the accepted higher. So in time, that can become one of the differentiators if you want to look for good papers. So these is in a nutshell all of the lessons that we learned, and that's what we had to say. And later on, we'll also share the references where you can look at all the data. That's it for us.
So thank you very much.
Great.
Thank you.
And
Thank
I
you,
believe
Martin.
I've
Thank
stopped
you,
sharing.
Anita.
Have I stopped sharing?
Yeah, you've stopped. Yeah.
Okay, fantastic.
Okay, and yet another reminder, please drop your questions into the question box and we'll pass it on to Tim.
Brilliant. Thanks very much. Yeah, thanks for the invite to talk today. This is great. So yeah, I think there's a great sense of unease in the research publishing community at the moment. And I think a lot of these feelings around research integrity are fueled a bit by a sense of perhaps a sense of betrayal as well, that the old system from way back when researchers, we could assume as publishers that the researchers were sort of doing their best, working diligently and genuinely trying to move science forward. And on our side, we would review the papers on that basis, trusting that the work we were being sent was a honest representation of what they'd done and that they were all on the level. And now that sense has been shattered, that we've realized that actually there's a lot of researchers out there who are not on the level, who are sort of trying to defraud us, trying to cheat us, trying to get work into our journals that really shouldn't be there. I think that's very much undermined that social contract that we had with the research community. I mean, to put it another way, the Mertonian norm that was laid out all those years ago of organized skepticism, that is the sort of peer review process, that skepticism has had to expand from is this work, are there alternative explanations for this work, for the results that the authors are presenting here, to skepticism around, are these authors real? Is this article real? Did anybody even do this work? If all these authors and people are actually real people, how many of them are trying to scam us? How many of them are trying to pull a fast one? Are our editors trying to pull a fast one? Are our reviewers trying to pull a fast one? And so the things we need to be skeptical about has vastly increased over time. And this means that the publishing infrastructures, as many have pointed out, that were based on this sort of community of trust have now got to be reworked and retooled to be skeptical about so many more things. And that's kind of part of why we're here with this webinar, is talking about the tools that we can bring to bear on being skeptical about so many different aspects of the research process. And I want to say that it's very hard not trusting. It's an exhausting process, not really believing anything your researchers are telling you. It's a difficult place to be. And so I wanted to change the mood a little bit and talk about positive signals and talk about things that researchers do that really help us believe them, that are an inherent feature of their article that actually, if we can detect these clues, that we can really start to trust that the work they've done is genuine. So here I sort of spread research out along an axis. This is sort of where I'm driving at, is putting the research along this axis of bad, that is fraudulent, the authors are cheating somehow, they are misrepresenting what they've done or whether they've done anything at all to try and get the article published. Then there are indifferent researchers that are really just churning out research as part of career, moving up the academic ladder. And then the researchers doing well, but they're maybe, you know, under so much time pressure, they can't really lean into doing great research. And then there are researchers doing genuinely brilliant work. And a lot of the research integrity checks that we talk about are all focused down this end here. But what's happening up here? And I think the SciScore presentation we just heard really gets into this area too. Like, what signals are we picking up from the article that the authors actually care what they're doing? And as you can see from the studies they've done, that there really is this signal in there, and that within the article, and it can be used to, and it has impact downstream on how well the article goes on to do. So I want to talk about transparency, because transparency and the sort of sunlight that we shed on the research process is by itself a very natural marker for research integrity. And so down over here in the bad sector, the researchers are allergic to transparency. If you are committing image fraud to fake the results of your article, the last thing you want to have to do is provide high resolution images of your results, so then people can actually look at them in great detail and see that you've manipulated them. Or if you are part of a paper mill, you don't want to have to submit a data set because it's just extra work. It's annoying. And so anything that detracts from churning out papers as fast as possible is not good work. And so transparency is an anathema down here. Then there are authors in the middle who are sort of working away, churning out research as fast as possible to get up the academic ladder. They're also not going to embrace transparent practices, because the time that you will be spending on making your data sets available, your code available, getting it ready to put in a public repository, you could be better spending on getting the next paper into the journal. And if there's no requirement to do it, why bother? Nobody cares. Let's just get the next paper out. Let's get that tenure track application in. And then only over here are the researchers who are really trying to push science forward. They welcome transparency because they recognize that the more transparent their results are, the more scrutiny they withstand, the more people believe them. The more people say, this is an impactful piece of work that really should change our understanding of the world, and we should go forward with this knowledge. They're really trying to have an impact, and they recognize that impact comes from creating trust in the work that you've done. And so it's these researchers that we want to find the signals for. And one powerful way of translating this sort of embracing transparency is looking at how the authors behave around open data and data sharing. And so over here on the left, the authors are not going to share anything, or if they are going to share data, you really have to push them to do it. And then the sort of gradation, the next sort of gradations is, okay, sure, you said, okay, you have to share your data, but then maybe all you need to do is to say it's available on request, or it's available in the supplemental material, and maybe they put one data set in the supplemental material. That is not easy to find. It's also a very easy option it's a very low effort option on the author's part just to bung some data set into the supplemental material, or even worse, say that it's available in the supplemental material and not actually put anything in there. And then a bit further along, the authors can share 1 or 2 data sets online. They can put something on a repository. And then at the very right-hand side, they can share multiple data sets and their code objects. And they can really try to make the article, rather than just a text description of what they've done, they want to make it's a complete research package. Here is all, not just the text, but here's all the information you need to understand what we've done, and our IDs and things like that, to make it fully reproducible and recreatable. If you want to start from scratch, here are the reagents we used, here are the programs we used, and so on. And so where does Dataseer fit into this? So what we have developed with Snapshot is a tool that allows you to stretch researchers out along, or to stretch the manuscripts out along this line. And this has a lot of benefits. What does it do? It first, it's essentially an authenticate-like product. You send the article to us by API at whatever point in the peer review process you choose, at initial submission, at the editorial checklist, at revision, and within a minute you get back a response that the editorial office can act on. So did the authors include a data availability statement? Do they claim that the data are available on request? Did they share any data sets in the supplemental material? Did they put any data on the public repository? Did they use multiple repositories? Was any command line software used? And so command line software is more sophisticated generally, and it leads an audit trail of what you've done. Something like Excel, if you use Excel for analysis, or GraphPad, there's no necessary audit trail of how the statistics were conducted. And so you can't make the article as easily reproducible as easily. You can't take their data sets and necessarily get the same numbers out. And if the authors did generate shareable code, did they actually share it? Where did they put that so that others can come back and look at it? And so these gradations of transparency mean that within a few seconds, the editorial office is saved the task of the way they would regularly do this sort of assessment, because this is part of a lot of editorial office workflows already. They are saved the effort of clicking the button, opening the PDF, scrolling through the PDF, trying to find the data accessibility statement, checking that it's got the content they're expecting, having a quick look to see what kinds of data sets the authors are producing, trying to find links to open data within the article, because sometimes they don't put it in the data accessibility statement, they actually put it somewhere else. All of this information is extracted by Dataseer Snapshot and presented to the authors right there in the editorial system. And so it's vastly more efficient from that point of view. Okay, I imagine there will be questions, so I will stop there. Thank you so much, everyone.
Okay, thank you, Tim. And then our last but not least presenter, Adam Day. And again, please go ahead and drop your questions in the Q&A box, and we will get to those when we have the discussion in a few minutes. So Adam, go right ahead.
Hopefully you can all see a black screen. That's not an accident. It's meant to be there.
Good.
Yeah, I'm Adam Day from Clear Skies, and I want to take us back a couple of years when, let's say about 2022, there was no automated way to detect milled papers. This was a serious problem, and people were really waking up to how serious it was at that time. The journals market had been growing solidly for decades. So what we have is tens of millions of papers. What we have to do is find in amongst those tens of millions of papers, the very few that have got telltale signs of research fraud. And the solution to that problem is called the paper mill alarm. This was released in 2022, and it was the first service that automates paper mill detection. For the purposes of this presentation, the green represents the good papers. There's loads of those. Okay, they're easy to find. The reds, those are the problematic ones, and there's just a very few of them for every for a large number of green papers. So what our AI is doing is it's taking these papers and it's learning what are the differences between the good guys and the bad guys. And the output is something like this. This is data visualization. It's actually explorable and interactive. So the publisher can look at this and they can see not just the individual articles that may be problematic, it's also seeing the patterns in them. It's seeing which subject areas, which journals are being targeted, and which authors are doing the targeting. The other thing that we do quite extensively is network analysis, and that's about joining things together, looking at the connections between things. Here we've got authors, and where they're joined together, that means that they co-authored on a paper. In this case, this is a group of people. This represents, I guess, a small community of people. The red lines represent papers which contain tortured phrases. Tortured phrases are a rare but quite powerful signal of research fraud. So in this case, we have this very rare signal that comes up quite often when we look at just this small group of people. So perhaps this whole community is worth looking at in more depth. When we put all of our network analysis together, we get something which we call Keystone, which is just about understanding which individuals have the highest rate of connection to signs of paper milling. In doing this kind of work, there's a huge amount of testing. Testing is really where I think most of the innovation in what we do is. It's a bit like editorial. So when you publish a journal, the value comes from what you put out, but the value also comes from what you don't put out. So we take, for example, we have, let's say, a bunch of data pipelines. Those go into some method which works out which ones are the good guys and which ones are the bad guys. Well, we can test this. And one thing we can do is we can say, well, let's say we've got one pipeline in here, which we know on its own is very powerful and very much able to do the job of testing, of predicting which papers are good guys, which ones are the bad guys. Well, what we can do is we can just take it away. And what's really strange is that when you do this, your overall prediction sometimes gets better. You can take away a powerful predictive method and your prediction will get better. And you can keep doing that. Just try it with all of the pipelines. And eventually you realize that some of your pipelines weren't as powerful as you thought because they actually don't add anything when you have other pipelines that do similar things, possibly even with different data. The results of all of that work, I think, speak for themselves. We've got the best estimate for the scale of the problem. Actually, that's probably the second best now because we have a better one. But you'll need to follow my blog if you want to learn a bit more about that. We have very high recall on Hindawi's retractions. We predicted every journal on the Chinese Academy of Sciences early warning list. We predicted the Web of Science delistings. And basically the result is that if you use the paper mill alarm, you scan every paper that comes into a journal. The paper mill alarm prioritizes those for you by giving you alert ratings. All we need to do is send those to good referees. And then the alert rate goes down, which is exactly what we want. And so all of that data analysis and all of that testing and all of that work boils down to giving a very simple alert rating on the paper. And it's very straightforward to action that. This comes in right at the start of peer review. So we see this before we even begin the peer review process. If there's an alert, the advice is get good referees. If there's no alert, just peer review as normal. One thing that our data shows is that peer review is very effective at dealing with paper mills. What we're doing is we're supporting that and making that easier. There is nuance here, but at a simple level, we can actually just get very, very far with just these alert ratings. If we take a peer review system, then the way that an integration would work is that we have an alert comes up in the peer review system and a link. It's dead simple. So what we can do is we can action the alert straight away by saying, okay, let's just get this to good referees. But if we want to go into more depth, we can go through to the website and look at the individual reasons why that alert is there on individual articles. We can even give feedback as well, so that we can use that to update our methods. And then we can go and look at the portfolio level. So we could look at the whole publishing house and say, okay, this publisher has had a problem which seems to have got worse over time, and then it got better. So that's good. But if we drill down into a particular journal, we can say, oh, this looks like it's getting worse. The red alert rate is going up. So we probably need to focus on this one. But fundamentally, it's an adaptive system. So the paper mill alarm produces alerts. The publishers act on those, and they can give us feedback, or actually we can just analyze the data and work out where new signals are coming in and how to model those and respond to those properly. So this is all governed by a data sharing agreement, which means that the publisher has full control over their data and ownership of their data. Now, we also have a browser extension. This is quite new, something that we're just testing at the moment. So if you'd like to try it, get in touch with me and we can get you set up there. Okay, well, thanks everyone.
Okay, well, thank you, Adam. Thank you, everybody. So we have several questions that have come in, and I think there is also an opportunity to have an interesting discussion around some of sort of the tenor of a couple of the questions. And so why don't we start with just some of the more basic bits of information. So DK, are you with us here?
Yes, I am still here.
Okay. So there was a question around integration into there were a couple questions around integration with peer review systems, and where I think obviously people want to include it into their in the workflow. Maybe you can talk a little bit about what systems do have an integration, and what why you don't necessarily need to have a particular integration with any particular system. So
Right, absolutely. So the way Convey has been designed, it can be used as a standalone application, as a tool that sits outside of your normal workflows with other products and tools that you may be utilizing at your organization. It does have plenty of features that allow organizations to have a streamlined and efficient workflow to request, receive, and review disclosures right within Convey. But to make it even one step simpler, we do have integrations with systems like, on the publishing side, we have integrations with Editorial Manager, eJournal Press, and then we are also finalizing and testing our integration with Digicore Pro. But essentially the way those integrations operate is that information from the peer review management system about the authors will come into Convey, basically identifying who those individuals are that need to submit a disclosure for a given manuscript. Convey receives that, handles the requesting of those disclosures from those authors. Once disclosures are received in Convey, that data then flows back into the peer review systems. And just as a side note, integrations are not just limited within the publication space. We do have integrations with other systems like Ethos CE, which is an LMS within the CME space. We also have integrations with Microsoft Dynamics, Salesforce, Workday. So it is a system or a tool that was designed to be easily adaptable to integrate with other products as well to make life easier.
So Anita and Martine, I think sort of a similar question to you guys is, if you don't want this as part of your submission workflow, or if there's, reasons why you don't have those in place now, what are people's options around utilizing SciScore? Well, Anita, you're on mute again.
One of these days, I'm going to learn how to use that button, not today. It's actually, there's a standalone version. It's at SciScore.com. So you can use that. I'll be more than happy to set up a trial for you. So you can take a look at what that would look like for your journal. It takes time for for someone to copy and paste a set of the method section into a box. We, on the editorial side, we definitely would prefer to have the author do that as opposed to the journal editors, but especially for relatively lower throughput journals, that's a really easy way to try the tool out, to also see exactly how it works, see what it gives you. So it's a low energy version of being able to do this. So please come talk to me. I'm Anita at SciCrunch. And you can actually log in and try it yourself. Use the legacy login if you want to get a couple of free credits. And then, we'll ask you to pay for it because that's how we also make money. But if you are a journal user, you should be, able to trial this out. So just come talk to us.
Yeah, maybe one addition. So we're now integrated in EJP Editorial Manager and very soon in Digicore Pro. And we also work with a number of institutional clients. And so so what happens there is that they have a sort of a suite of tools that they use for checking the publication before it's sent out to a publisher. And so then also the paper or the manuscript actually is then checked by SciScore, but also by Authenticate and other tools. So the institute knows for sure that what goes out is actually decent, irrespective whether the journal is integrated with SciScore or not.
Tim, do you want to address that too?
Talk about integrations, yeah, sure. So we are talking very much to integrations. Obviously, we wanted to get integrated with Highwire. We're working on that. It's very simple as an API. If you want to get going right away, we can also make use of direct emails out of the editorial system. I've worked with ScholarOne for many years, and so you can actually set it up so there's an event-driven email would come to us, and the email would come back to the editorial office email inbox. And that's not an API-dependent setup. It would be very simple. You could trigger it yourself as the editorial office, or you could trigger it as part of an event. So yeah, it's a relatively new product for us, so we haven't integrated it everywhere, but there's a very long queue right now of integrations that we're working on. So please do get in the queue, get in touch with us if you'd like to be involved with that.
And so, Adam, you've been integrating with the STM Integrity Hub, and what else? How is that going, and what else else are you?
So we've discussing a lot of integrations with different partners, and ideally we want to make sure that the tool is available at the point of use for um, any publisher who wants to use it with whatever tool they want to use. So usually the ideal is a peer review system. But there are actually a lot of other places along the workflow where it's worthwhile performing checks. And really, yeah, we're interested in integrating in all these places, but we've integrated with Editorial Manager, STM, and with Mercier. But we have about another 3 or 4 integrations which are underway, and including working with MPS, which I'm very excited about.
Okay, great. There was I think a sort of larger philosophical question, and I saw it reflected in a couple of comments around the idea of research integrity being a concern, of course, in that, as all of you have been talking about. But is it what is the role of the journal and the editor in evaluating the evaluating research integrity questions with regard to maybe their own conflicts of interest? Do you think that maybe as one of the questioners put it, that editors retracting articles without following their own procedures, censoring information that they don't want the public to see, instead of allowing the publication and other scientists to publish arguments against the publication? Do you think that from your experience in working now with people for so long, with journals and editors for so long, do you think that is a big concern, or do you think that that's something that I guess, rather than giving you a either or, what can you just comment on maybe what you think about that sentiment?
I could take that one. I guess my view on that is that having worked in editorial for publishing house for a long time, I think that's a part of the process that creates a huge amount of value, which actually is never seen because no one sees that you don't publish something. But anyone can put a paper, a PDF on the web somewhere. They could post it to a preprint server. They could post it to their own website. That on its own is not a good way to publish and not a good way to get read, or not a way that would be valued. The value comes from the fact that journals are selective. And so if you get into a journal, it shows that you have met some quality criteria. And that is what I think people want. They want to have that service there. So yeah, I think, there's a lot to be said for doing a lot of work to support science and help people who are really trying hard to do good work. But I think that the value of a journalist is diminished if there is no editorial. The editorial really has to be there, and it's about what you don't publish.
Yeah, maybe to add, I think retracting a paper because you don't want the public to see it is quite a big step and involves too many people. So, at least the papers or the journals that I ran when I was at Springer, if you want a retraction, you need approval from so many others that you can't do that sort of in the sidelines. Delaying a peer review decision because you're reviewing a competitor journal, paper, while submitting your own paper very quickly to bioRxiv. That's something I can't exclude, but that's, yeah, a little bit more wheeling and dealing.
Anybody else want to touch this somewhat controversial question? No?
Well, the question is, what is the role of the publisher, right? At its core, what is the role of the publisher? And if the role of the publisher is, as Adam and others say, to include some things and exclude other things, not just, to get whatever, money is associated with that, then the role of the publisher is to also exclude those things that might be fraudulent and or might be very low quality, or might be other things that are undesirable. And so really, I mean, in our current system, the role of the publisher is to select. And these tools can help, but ultimately, the publisher needs to make the decision as they have been, made to, or they've stepped into the role of making those decisions. So it is incumbent upon the publisher to actually publish real work in as much as they can possibly detect it. I mean, there are obvious places where there is fraud that is discovered, years or decades later. We are dealing with some of the cases of those things. One of the questions is, could we have detected those things earlier with things like, image manipulation checking, with asking for proper disclosures, with asking for all of these things? Perhaps, and I am certain that some fraud will always get through because the fraudsters get better as we get better at detecting them. But this is the fight, right, that the publisher is ultimately taking on. This is the publisher's role. Otherwise, we can just publish everything on the preprint servers and let post-publication peer review deal with it. But I think, again, there's a role for publishers, and if there's that role, it's selection.
So, Tim, you brought up during your presentation that we kind of focus on the signals that show us the signals that show us what's wrong, what's not, what is the signals of fraud, and that you brought up the point that there are actually positive signs and signals that we kind of ignore. And I thought that was a particularly interesting point. And then, it was also brought up in some of the questions about, we're weeding out bad actors. What can be done to, sort of look at how we can strengthen the scientific record in what's being published. So I thought that was an interesting point. And so I don't know if, would you like to expand a little bit on the thinking?
Absolutely. So I have to keep this very short. So I used to be an evolutionary biologist, and honest signaling is a huge topic in evolutionary biology. It's a candidate for why, for example, peacocks grow such gigantic tails, is because they are associated, they are thought of as an honest signal of the male's quality, its ability to gather enough resources to grow such an extravagant, brightly colored item and then survive dragging this stupid thing around behind it, and not getting eaten by a tiger. And so it's an honest signal in that you can't do this unless you are in great condition. And so expanding that sort of idea to academic publishing, we are looking for signals that the authors care about what they're doing, that they have they've put in the extra effort to make their data publicly available. They've put their code and their data together, and it's because they care about what they're doing. And so, yeah, there are lots of honest signals. I mean, SciScore detects a lot of other ones too. that the authors have thought, okay, what do I need to do to convince people of the results in this article? What are the signals I can include here to show that I actually really know what I'm doing, that I care about what I'm doing? And a shockingly low proportion of articles actually bothers to do that. And so that's why these signals are powerful for academic publishing to help find and promote authors that are really doing a great job and tell their stories.
And can I just add to that? Looking at RIDs across the scientific literature is one absolutely wonderful signal at this time. At some point, some actor that's, unscrupulous will use that. But I think we're a few years away from that. At this point, we're still hitting just about 20-25% of the literature that we need to be hitting. And that 20-25% is typically the people who go the extra mile, those people who really care. So at the moment, it is a fantastic signal to look for in your editorial process. If there are a lot of RIDs, it means that someone has gone to those extra lengths in order to ensure that the reagents are what they say they are, in order to ensure that their reagents are actually authenticated as required by their funder, most likely.
Great. And so we've been talking about signals and scores. And so Adam, Anita, Martine, you guys have a signal, a score that comes up that gives indications of quality. Tim, I don't think that your system has that as part of an output, right? Does it give a signal or a sign or a color code?
Yeah, it does actually. We can make a composite score based across all the things the authors do. And we can tweak it a bit, but it currently ranges between -3, where you do things like this article, have a data accessibility statement that claims there is no data associated with this article, and there clearly is, so that's lying, or we shared all of our data sets and supplemental material and you didn't.
Okay.
All the way through to the authors that share data sets share multiple data sets on multiple appropriate specialist repositories and share code and put it into Nodo rather than GitHub and that sort of thing. And that's sort of how to max out your score there. There are other metrics that we do that we haven't integrated into Snapshot yet. So for example, use of protocols. Do they use protocols.io? Did they pre-register the research? Did they what's the other P? Did they preprint it? So yeah, there's other things that we could include there. But right now it's very, very much an editorial office tool for editorial offices that are doing some sort of check on data sharing and have to sort of slog through the manuscript for 5 to 10 minutes to find all that information. It's just pulled out of the manuscript and presented right there to the editorial office so that they can get on with their day.
Yeah, I guess I just have one thing to say there about I think about Goodhart's law a lot, which is that if a measure becomes a target, it ceases to be a good measure. And I think we've seen this happen with the way that people get measured in Scholcoms generally, where a researcher will be measured by their output and by citations. And so we see a lot of practices which are sort of geared towards gaming those metrics. So I quite like the idea that instead of having positive signals, we have an absence of negative signals as a positive signal. I think the thing I like about what we've all sort of spoken about here is that there's a lot there that is positive signals, but signals that are in quite a wide range. So for somebody to go to the trouble of baking all of them would be very, very hard. But I quite like this idea of like, let's look for an absence of negative signals, and that actually in itself is a good thing.
So DK, Convey doesn't have a score or traffic lights or anything like that. Is that right?
Not at the moment. I think there needs to be a little more engagement from the community and having seeing some of those standardized forms and mechanisms for collecting disclosures, right? I mean, currently we have a standard process, but I think the community really needs to move towards a more harmonized collection process as well. As far as requirements, we have a lot of variables in place for societies. They have a completely different set of requirements versus the journals. And then you have academic institutions in the mix, which have far more stringent requirements for what they need to collect for disclosure. So I think as we move in that direction of having a more harmonized set of information being collected, I think it will be a lot easier for us to develop those signals and triggers that essentially provide an alert that perhaps this person has either missing information or just inconsistencies in their data. But one of the things that we have implemented is the open payments data is now integrated with the Convey information as well. So both individuals can look at their own profiles in their CMS open payments for those that are that do have publicly available information in CMS open payments. I understand that may not be available for everyone. But individuals are able to look at their own information, along with organizations now have a mechanism in Convey itself for them to be able to compare someone's open payments profile against what they have submitted in Convey, so that it just makes it one step easier for them to have that comparison tool.
Thank you, DK. The Kushal, the man behind the Highwire Press logo, is going to be dropping a link to the to a form for the attendees. So it just has 3 questions. It's just the post webinar form, but I'm letting you all know now that that's being dropped. He's done that. He's dropped that into the chat. So please don't go jumping there yet. You can go ahead and click on it and let it open in your browser, but we still have a couple more minutes here, so don't go rushing off to the evaluation form. I just wanted to let everybody know it was there. And so DK, there was a question about security of the data that is in Convey, and I don't know if you want to address that, because I think that particularly when we're dealing with conflicts of interest, that's certainly an area that in personal information that's important.
Absolutely. So a couple things there. The AAMC, the Association of American Medical Colleges, runs very highly sensitive programs here, like the MCAT, like the electronic residency application, and the medical school application service. So if you may be familiar with any one of those do require applicants to submit transcripts, letters of recommendations, etc. That is also very, very sensitive information. And so in order to keep all of that secure, AAMC has very stringent policies around data security, privacy policy for use of information, etc. So we do guard that very, very closely as well. Some folks may interpret this question as more of, is Convey sort of like a publicly available database that anyone can just come in here and peruse through a submission that was made to the New England Journal, for example? That is not the case. Disclosures that have been submitted to a specific organization, only that organization will be in control of viewing that information. So just wanted to make sure that there were both sides clarified there.
Okay, great. Does anybody else want to talk about the security around the data that you're holding? It's not quite the same situation.
No, we don't. We only receive the apps, the method section, and sometimes a manuscript number, but even that can be scrambled. So yeah, and we delete everything after a certain time. So there was one question maybe for you, Tony, about the different tools that are being integrated in DigiCore Pro and how that works together.
Yeah, well, I think that one of the questions, one of the ideas behind the discussion of all of these different the different scores in the different traffic lights is it can be a little bit of sort of trying to compare apples to oranges or apples to trees or something. And I think that each tool that's out there, the tools that we've been talking about today, and other tools that we've looked at around research integrity or quality check, there are different. Authenticate has a score. There are other tools that have scores. Understanding what that score means really is specific to the tool itself, and so I'm not really sure how to answer that question because the tool, you have to know the tool, you have to understand what the tool is providing to understand really what that score means. And so I think that's really the point, is that you don't want to just trust a score. You want to use the score as a guideline. And as Adam said, we don't want people to work to satisfy a score. The score has to sit independent. So Anita, you're unmute.
Except in our case, we actually do want people to satisfy the score. We want them to game the system, because gaming the system means that what they're doing is they're looking up their reagents and they're actually, addressing the transparency measures that they're supposed to address. So in our case, we want the people to game it. Like, please game the system, because we want them to say, hey, I didn't blind this study. And that counts for, positive, score in the system, but it basically improves the transparency. So while I agree with Adam in many, many ways, on this particular point, I disagree with you, Adam. I think at least for us, we absolutely want people to game SciScore. We created it as a checklist of 1 through 10, so that, if you get a 6, then you're really getting an F. That's 6 out of 10. That's maybe a D. I don't know which metric system that you like to be in. But the goal of SciScore for us is to improve the number of things that people address in their study. And the number of things are, prescribed by these various checklists. So even if it's addressing them in the negative, it is already a far better thing to address them in some way. And an honest, author who says, hey, I didn't blind my study. Awesome. You've at least made that transparent in your paper. And so you should get kudos for that. And the reviewers should be able to see that. So I love the concept that Adam is talking about, but in this case, I just have to disagree.
And we do get authors on a regular basis who email us and say, hey, I want to get an 8. How do I get there? So that's always admirable.
Okay, we are at time, and so I want to thank all of you for helping with this webinar today, and I want to thank the audience as they begin to trickle out. Thank you for attending, and this will be recorded and on the YouTube channel. So thanks again, everybody, and it was